This is the Core 2 video for the pumpkin chunker demonstration. We watched videos of actual pumpkin chunkers in the Aurora pumpkin chunking contest, and this demonstrates how the angle of elevation affects the distance that the pumpkin flies, or the pumpkin's trajectory. So I'm going to fire the pumpkin at an angle of elevation about 20 degrees. So this angle is 20 degrees. So the pumpkin at 20 degrees, the pumpkin went about 390 meters. I'm going to reset the angle. I'm going to make a really high angle, really steep angle. We'll try 65 degrees. We'll fire the pumpkin. Yeah, you'll notice the pumpkin went a little bit farther, maybe 395 degrees. I want you to look at the trajectory, though, the path of the pumpkin. You'll notice it looks similar to the graphs that we did of quadratic equations. We're going to talk more about that. Last thing I want to do, though, okay, got my pumpkin chunker again, and it went about 390 degrees when it was set on 20 degrees. I'm sorry, 390 meters when it was set on 20 degrees, 395 meters when it was set about 65 degrees. I'm going to set it at 45 degrees now, approximately 44.9, really close to 45, and see what happens. It doesn't go as high as the 65 degrees. It goes higher than the 20 degrees, but it goes farther than anything, about 540 degrees. I'm sorry, 540 meters. Okay? So the angle of elevation has an effect on the path of the pumpkin and the distance that the pumpkin flies. We're going to use a function to model that effect. And when we say a function, I'm going to say h of d, actually I'll just start off with h of t equals 4.9 t squared plus the initial velocity v times t, I'll say v0 times t, plus h0, the initial height. Give me a moment. I will. Okay, oops. There we go. I'm using subscripts. Subscripts are numbers that go below. And that shows that gives me a better idea what the velocity is. It tells me that v is the velocity. The v0 tells me that's the velocity when time is 0. h0 tells me it's the height when time is 0. We are going to use this equation to help us calculate what happens to the pumpkin.